Ever gazed at the moon and wondered if it will always be there, just like that? Well, hold on to your telescopes, because the moon is slowly slipping away from us. Today, we're diving into a cosmic phenomenon that might just blow your mind. Did you know the moon is slowly drifting away from Earth? And get this, it's leading to longer days on our planet. Stick around to find out how and why this is happening. Our moon isn't just a pretty face in the night sky, it's gradually moving away from us. This may sound like science fiction, but it's a scientific fact. The moon is currently drifting away from Earth at a rate of about 3.82 centimeters per year. To put that in perspective, that's roughly the same rate at which your fingernails grow. So, why is this happening? The answer lies in the gravitational interaction between Earth and the moon. As the moon's orbit widens, it's slowly pulling away from us. This process has been ongoing for billions of years, ever since the moon formed. Think of Earth and the moon as dance partners in a slow waltz. The gravitational pull between them acts like a tether, but as the moon drifts away, that tether stretches. This causes the Earth's rotation to gradually slow down, much like a figure skater extending their arms. This gradual slowdown is why our days are getting longer. It's a tiny change, almost imperceptible in our daily lives, but over geological time, it's quite significant. To understand the full impact, let's take a trip back in time. Around 1.4 billion years ago, a day on Earth lasted just 18 hours. That's right, our planet was spinning much faster because the moon was much closer. Fast forward to today, and our days are 24 hours long. But this wasn't a sudden change. It happened gradually, over millions of years, as the moon drifted away. What does this mean for the future? Scientists predict that in about 200 million years, a day on Earth will be 25 hours long. Imagine having an extra hour in your day, more time for sleep, hobbies, or maybe even work. But let's not get ahead of ourselves. This change is happening at a snail's pace, so we won't be around to see 25-hour days. How do scientists know all this? Enter astrochronology, a fascinating field that links astronomical theory with geological observation. By studying ancient rock formations and sediment layers, researchers can trace the history of Earth's rotation and the moon's orbit. One key study examined rock sediments from a 90-million-year-old formation. These sediments hold clues about Earth's past climate cycles and rotational speed. By analyzing these layers, scientists can determine how long days were millions of years ago. Why should we care about the moon drifting away? For one, the moon's gravitational pull plays a crucial role in stabilizing Earth's axis. This stability affects our climate and weather patterns. As the moon moves further away, these dynamics will change. The moon also influences tides. Higher tides, known as spring tides, occur when the moon is closest to Earth. As the moon drifts away, tidal ranges will decrease, potentially impacting coastal ecosystems and marine life. This phenomenon isn't unique to Earth. It's a common process in planetary systems. Our moon's gradual escape is part of a larger cosmic dance involving gravitational forces and orbital mechanics. Understanding these processes helps us learn more about the evolution of our solar system and the dynamics of other planetary bodies. So next time you look up at the moon, remember, it's not just a beautiful sight. It's a dynamic partner in our cosmic dance. And while it's drifting away slowly, it's leaving behind a fascinating story written in the rocks beneath our feet. If you enjoyed this dive into our moon's journey, don't forget to like, subscribe, and hit the bell icon for more cosmic tales. Until next time, keep looking up